All right, thank you, Jim, for that introduction, and good morning or good afternoon, depending on where you are in the country or the world. Love to see such a diverse group interested in traffic incident management. Today, I wanted to discuss Seattle's cloud preemption project. Next slide, please. And Seattle is well known for clouds, but of course, that is not the type of cloud I'm talking about today. Today, I want to discuss a network of remote servers accessed over the internet. And by preemption, I mean overriding the normal sequence of timings of a signalized intersection to deliver a green light for emergency vehicles. Today, I'd like to tell you about Seattle's project, describe some of the basics of traffic signal preemption, some trade-offs of a line of sight optical system versus a cloud system, and share our findings. Next slide, please. Preemption was an important piece of a much larger project in this area shown. Every project seems to need an acronym these days. So this is our Multimodal Integrated Corridor Management for All, or MICMA project. And we're very grateful for grant funding from Federal Highway Administration. So I'm showing part, actually go hold there, please, yes. I'm showing part of the university district around the University of Washington. It's a large urban campus, over 52,000 students, surrounded by water. So we have some limitations on alternative freeways and arterials. The project area encompasses approximately 50 signalized intersections. And next slide, please. The university area just has ubiquitous constant pedestrians and cyclists, large volumes of transit, 2 light rail stations, football games and other major events and incidents all put stress on our transportation system. With all these challenges, we need to maintain access to the University of Washington Medical Center and expedite emergency vehicles throughout the area. Next. The project also included adaptive traffic signal control, extensive improvements of vehicle, pedestrian, and cyclist detection, and several other elements. But what I really want to focus on today is the last bullet point here, cloud-based emergency vehicle preemption. Next. So our Seattle fire vehicles were already communicating their position to our dispatch center. So with this project, we now have the dispatch center automatically sharing this with Light's cloud server, which determines when to request traffic signal preemption. Next, please. But first, I want to share this simple model of an optical preemption, which I guess I can call the old way. So an emitter is installed on the apparatus. So near the light bar, there is a device sending a flashing light encoded with a short message that identifies the apparatus. A detector is typically installed near the traffic signal displays and transmits that message to the traffic signal cabinet, which terminates conflicting movements and delivers green lights to the emergency vehicle. This does require line of sight, so that we have major constraints with trees, horizontal and vertical curves, buildings, and just some limitations on the equipment. And so it's pretty common, at least in this part of Seattle, it'd be very common to be limited to 400 to 600 feet maximum of visibility. Next, please. The light preemption architecture eliminates this line of sight requirement. The apparatus transmits its GPS location to dispatch, and computers take over from there and send an NTCIP 1202 message to our traffic signal controller requesting preemption in a specific direction and to achieve the same result. Next, please. So how do we know when to initiate preemption? So in the light interface, it's really simple. We really just draw a zone. And if the emergency vehicle is responding and traveling toward the traffic signal, then it is eligible. And we calculated this real simple method for our kind of first draft based on the desired travel speed of 30 miles per hour. And then we assume what's the worst case for the traffic signal. The worst case would be that we're currently serving a conflicting pedestrian movement that we need to terminate, and so that's going to take some time. In this example, the FDW, or flashing don't walk, is the pedestrian clearance interval, the normal time to communicate to pedestrians that their turn is over, and the yellow and all red interval in this example takes 26 seconds. So that would require over 1,100 feet of detection. Next slide, please. The cloud advantages we found is really rapid deployment of the emergency vehicle preemption system. We've eliminated much of the equipment in vehicles and at intersections and traffic signal cabinets. Most importantly, we have a higher probability of a green light. We have a very simple way to monitor the system performance through a web portal. But one caveat or drawback, it does require network communication. So if you lose communication from your city hall or your central system to the field, then you will not be able to provide emergency vehicle detection. So this is a very important tool. So consider that and consider upgrading your communication system if needed. Next, please. We did discover a very reliable uptime, over 97%. I think we can do better than that. Most of our limitations there, I think, were communication issues on our end. No real issues with the vendor. And we found it very effective at delivering green lights for emergency vehicles. Before and after study increased the provision of green lights from about 59 to 76%. Well, that's a big change. I think we can do much better. And I think as we continue to use this system, we're going to adjust the zones and make some other adjustments to how it works, in hopes of getting a much higher percentage of green light. Travel speed through the intersection improved, which gets the emergency responders to the scene much sooner to help save somebody's life, hopefully. An important finding was very important to talk to your emergency vehicle drivers. They know some of the really unfortunate things that some general purpose drivers may attempt to do while trying to get out of the way of the emergency vehicle. So riding along with them in the apparatus was very educational. And next, please. So these are preliminary results. We do plan to examine the fire response times in much greater detail. We would like to increase our system uptime from 97 to well over 99%. And I think we can increase the green light provision, or the delivery of a green light to the emergency vehicle, from the current 76% to hopefully 95%. We would like to expand the system to other corridors. We're actually doing that right now, this very week. And we're also planning to add transit signal priority using a similar product from Light. And the city is not in a position to recommend a particular product, but we are very pleased with this type of technology. There's other competitors to Light who are also in use in our county, and I think it's just a very exciting way to improve emergency vehicle response. And next, please. And thank you for listening. And with that, I will turn it over to Laramie.
We have some questions here. We have about 20 minutes left. And I'm going to get right to a couple for Bruce and Laramie, pardon me. What, if any, authorizing by the region was needed for emergency responder signal priority? Bruce or Laramie?
I think the question is referring to maybe other agencies within a region, other emergency service providers. And
sounds like it.
Can you hear me okay?
Yeah.
Yes. And To my knowledge, we have not really involved other agencies. In this particular area, there are occasionally um, emergency vehicles from another city, city of Shoreline or city of Bellevue might respond. And currently they would not be eligible for um, cloud preemption. That could be set up pretty easily though.
Yeah,
Hmm.
and that's what I've seen from my side too, is if there is that motivation for mutual aid, having other jurisdictions come into your jurisdiction and use your preemption, that is a city to city or city to county conversation. But with all that we see in terms of the capabilities of newer controllers, it allows for a lot of flexibility within the system.
Absolutely. Another one for you guys. What guidance might you offer for other regions considering cloud-based signal preemption technologies for emergency response?
I would say do it. Um, it's just a very effective way to get your emergency vehicles to the scene faster and safe, safely. It does require NTCIP traffic signal controllers. So there is if you have older legacy equipment or proprietary type of firmware in your signal cabinets, then you may need to replace some software or equipment. Um, and you need highly reliable communication. But other than that, um, you're pretty much good to go.
Yeah,
Go for it.
yeah. And from my standpoint, we really encourage agencies that are thinking about it, jurisdictions that are thinking about it, to just pilot. There are a lot of opportunities because there's nothing in the cabinet, nothing on the vehicles. It's a pretty quick thing to spin up. And at the end of it, we really want cities to fully vet the system. Don't give it the easy intersections way out of town. Give it the challenging ones and try it during difficult times of day. And there is so much data that you can iterate really quickly. Try one strategy on Monday, try one strategy on Tuesday. And by Wednesday, you would have the data to see which is the best for your unique operating environment.
Absolutely. Question for you, Ryan, similar to Laramie and Bruce. What, if any, authorizing by the state was needed for use or use cases of drones?
A lifetime of paperwork filing. I would file more paperwork than I fly. And I always, I never wanted to be in that position, but yes. I will say the FAA has been amazing here lately, with a lot of their efforts to get law enforcement underway. But I saw there was a question too for, can DOT and law enforcement both use drone dock and with Caltrans in Alaska? The answer is yes. If I had to do a quick explanation of it, currently drone docks are being operated from state agencies under public and civil operations. Caltrans, for example, operates under Part 107 and Alaska operates as a public agency. Each individual agency that utilizes that asset needs to either have a COA, which is a certificate of authorization from the FAA, and prior training that allows for them to operate that system either from Skydio or DJI or any of the other dock manufacturers. So FAA is not the item that is, I would say, roadblocking it. A lot of it at the moment is this technology finally is getting authorized. We're seeing beyond visual line of sight operations opening up for many departments. It's really just how fast states are adopting it. Learning from their mistakes, failing, or as we're doing, partnering together with other states so that we kind of crowdsource this and all learn from each other at the same time, which is really the benefit of all of this is taking what works
Absolutely.
someplace else, making our own flavor, improving upon it, and sharing it back with the group. So hopefully that answers the question. Is yes, there are it's basically just installing these docks, installing these technologies, cloud first on a lot of these pushes, and getting the correct partners in line to start testing and deploying these systems.
Yes, thank you for that. So another one for you, Ryan. What has the public perception been to the use of drones for emergency response?
We spent a lot of time, well, especially with this, it's like, hey, do you mind if we install this suspicious looking box in your neighborhood? Yes, I mean, we spent a lot of time, especially with Wrangell, where we had the landslide. We did have some folks that lost their lives in that landslide. And so we had to treat a lot of the data with sensitivity, but we did a lot of outreach with the community, with a lot of the students, with a lot of the folks of, hey, this dock is going out there, but what this is doing is it's checking to make sure, ground's not moving. So, we're not just showing up in these places, these communities, but we're making sure these communities understand, hey, that tool is keeping us safe. That tool is doing its job there. And we're definitely looking at that, especially with some of our SOAR initiatives, where we'll be installing these docks throughout Alaska, Hawaii, Oregon, and Washington, and testing these different environments. What works well in Western Alaska, with a limited population, probably will not work well in the heart of LA.
Sure.
I think that's exactly what we're looking forward to. Is we're going to fail our way through this together, find and learn from our mistakes, and continue building these. But public outreach is a crucial item so that folks are aware of what's inside that blinking box that's sitting here making a noise, and takes off every couple of minutes. So
Yeah, I remember our first exposure to UAS drones was the city of Chula Vista in Southern California. The police department there, they were launching drones from their I guess police headquarters to mostly for police activity, but ultimately were started to use it for traffic incident management. So we had a really cool collaboration with them for a while. I have another question for Bruce and Laramie. What future traffic signal upgrades may be a priority for existing signal systems before cloud-based EVP can be implemented?
I would just say reliable communication and an NTCIP traffic signal controller. That's it.
Okay.
Yeah.
Yeah.
I think one of the benefits of data standards is, I mean, light and cloud TSP would not exist, and EVP would not exist without data standards. And so it's just making sure that when you are looking for that signal monetization plan, that they adhere to data standards, because they enable a lot of plug and play, a lot of a lot of interoperability. And so a lot of companies and a lot of folks talk about interoperability, but data standards are the proof of that. And so making sure that they can speak the same language to each other is key.
Yeah. What would you say to uh, what would you say to municipalities, owner authorities that are considering EVP? And I know TSP's been around a long time, and the old, original Opticom systems and all that before the cloud-based stuff that you guys specialize in. And the reason I asked that question is because we don't know of too many jurisdictions, municipalities, like I said, and other areas that are employing EVP. What Why is that, do you think? Or is it the cost overall, or maintenance, or all the above?
In my opinion, it's it's a lack of data, and I think without data, you don't see maybe how bad things are. You especially if there was a legacy EVP system that was bought, that was purchased and installed, you think you have something, but without the data to prove its efficacy, you don't. Um, you may not be motivated to look elsewhere. You can kind of get anecdotal evidence from fire chiefs, but without the data to prove it, you may not see how far the floor has dropped out from the system that you purchased maybe 20 years ago.
Yeah. And
Jim?
and Who
I'm
was that?
sorry, this is Vaishali. This is Vaishali. There's a bunch of questions still in the Q&A. May I bring some of those up to surface for
Didn't we field a bunch in the Q&A earlier?
right. When we answer them in the Q&A, it only goes to the person who has been asking the question more often. So we try to ask them verbally as well so that everyone can hear the response.
Okay. Go ahead, Vishali.
Yes, so one of the questions was from Sean Laffey. In addition to the observed increase in green time for emergency vehicles, have you also realized any other benefits that Laramie mentioned, such as improved response time? And have you encountered any challenges with using the cellular network to request green signals, particularly during high volume events like football games?
So it looks like
I don't know
Bruce
if
answered that.
I'll chime in quickly. I think that answer only went to Sean. So for everyone's benefit, I'll repeat that. So the first question about reduction in fire response times. We've heard anecdotally the drivers are highly confident that they're getting faster response time. We have not investigated, but we can and we will do that from our dispatch data. Second question was, I think was asking whether at major events like a football game when there's a lot of cellular traffic, if there's any reduction in service or communication. And I haven't not aware of anything there. Our traffic signal communication is typically fiber optic that would be immune to that, but it's possible that the apparatus is competing with other cellular traffic. Laramie can probably speak to that better.
Yeah, and I can just say a bit under the hood is that that's one of the ways that we use machine learning is to kick out a lot of that GPS noise. Because especially in these, especially where there's a lot of competing signals, especially in, urban canyons, you can get a lot of noise. And so that's one of the ways that we use machine learning is to kick out the sources that we see as unreliable in that moment.
And then there was a question about how long the video is stored. And if so, who could potentially make use of that in terms of the light video that you demoed?
Totally. Yeah. So I think our default is to store all this information for a year. But that's completely customizable based on jurisdictional needs. I know if there are insurance requirements, grant reporting requirements, all of those can be tailored, but off the shelf, it's about a year.
Okay. And I think there was also a question for Ryan on, given the large volume of data, how is the storage and processing of that data better managed? And I personally have a question of how, if any way, is that data being shared with the broader Alaska DOT enterprise for other uses?
Yeah, so that was kind of the problem that we walked ourselves into is we gave everybody access to these data creation devices. And I'll be the first to tell you, we didn't know that we were going to redline all of our drives. I started with IT, was not big fans of us because we broke our network pretty fast. Shortly after that, we kind of went back to the drawing board where we structured, hey, here's all the data we're creating. Here's what can be stored. Here's what can be deleted. And so we went into that as we went into partnership with Esri, where they came in and kind of did a full system analysis of, hey, here is how we store items. Here's what goes into the geo database. And from there, we started breaking down a lot of the silos. Is now we can search all of our imagery that's created. As well as publish that to we have an Alaska Geospatial Council, which is all state agencies. So all imagery that's created by public agencies is available to the public. And so that then gets sourced up there from our image server. Same thing with video. Anything that is project related, we save for a year before it is deleted. But that's kind of where we're pushing a lot of it is, hey, we are bringing everything, we're processing it on-prem. So that's another big item is unlike the rest of you guys, I saw there's a couple folks from Alaska, but the rest of the folks in the contiguous United States, we don't have fast access to data centers. And so we have started building smaller edge compute centers around our state that we can send data to, process it, cut all the fat off, and only lift the final product to the cloud or Azure Washington Data Center West, which cuts down on a lot of our ingress costs to the cloud by not putting all of the raw imagery, putting the final product, moving it around. It's just a simple lift and we're done. So we're limited on bandwidth to the cloud and those items, edge compute, and having that pre-processing has done a lot for us into the geodatabase and environment that we have there for sharing all of that information, both geo-rectified and orthomosaics and video across our enterprise system.
Very
Well,
good strategy.
with that, we have 4 minutes left, and I want to first thank Ryan, Bruce, and Laramie for their time and outstanding presentations to the National TIM community. We still have over 140 participants with us today, and a huge thank you to all of them. I always take a couple looks at the participant list, and I see many of our champions, our partners across the nation that are interested in everything that you guys do. And I want to, besides sharing these resources here, these links to various resources, I want to say that the next 3 Talking Tims webinars are going to cover topics from the Everyday Count 7 Next Generation TIM Technologies for Saving Lives. Our contract team is already preparing of the 46 states, I think it is, that participated in EDC 7 Next Gen TIM. Over those months, starting in June, July, and August, the Talking TIM platform that we're on here today, Adam, and of course, Executive Director Nick Ramphos, that was also joined us today, are very kindly going to let us conduct those EDC 7 webinars over the next 3 months. So make sure if you're not registered that you do, that top URL there, and all the rest of those URLs there contain a lot of very important information, including the self-assessment, by the way. Let's see. Vishali, anything else we missed? We got 2 minutes, and then I want to say goodbye.
No, I think there were a couple of questions about the training site, and it will be live within the week or so, and you'll get a formal announcement from the team on that. And I know there were some questions we didn't quite get to, but we'll save that for a future effort, I presume. So
yes,
great presentations today. Great information.
Yeah, indeed, and many thanks to you, Vishali, for all your work making this happen. And I think that's a wrap. So everyone stay safe, keep doing great things, and head on a swivel, as we say, out of your car on our nation's roadways, a very dangerous place to be. So God bless. Take care, everyone.